cloud. All right, so I'm going to share my screen. Make sure by this time you have the handout handy with you, the unit conversion handout, right? We are going to use that during today's session. Also, make sure you have your calculator handy with you. You can use your phone or actual calculator, or if you don't have any of that, you can just Google the calculator and it will give you the calculator, right? So first session. All right, welcome everyone. First session, we are going to talk about the basic math problems. Uh, when you are taking this general chemistry or like introductory level chemistry classes, we do have to learn, or we do have to have a good foundation of math, right? I see like over the last 3 years, I have seen the student are struggling with the math a little bit, right? It depends on which background you're coming from. However, right, if you have a strong mathematical foundation, it will be really, really helpful. Then you find the chemistry as not that kind of, uh, challenging course, right? If you know the math. So what I'm going to do in the first session is we are going to talk about the basic math. If you already know, it's great. If you don't know, you can just, and you can recall the information. If you don't know, then you can learn something at the moment. All right. So remember, I'm not talking about the math, which is not going to be as a part of your exam. This, whatever we are going to discuss, you are going to see this question or similar question in your exam one, as well as some of this question will be in your final exam. So I'm not just kind of covering the basic math, I'm covering the material which you need to know and which will be as a part of your exam one and the final exam for SCC 110 or 201. So just remember that. All right, so first of all, let me just talk about that. We are going to talk about the basic math. Then we're going to talk about the measurement, what are the different measurement and the unit and the prefix. Then we're going to talk about significant figure, very, very important point or concept. And then we're going to do some math, right, in which we are going to use some formulas. All right, so I hope I can finish this all material today. If we can, we're going to continue working on this same presentation tomorrow, right? If you can finish it, is awesome. All right, so without the further delay, let's start. So first of all, what we are going to learn, we are going to learn about decimal notation to the scientific notation. It means we are, okay, I'm just going to minimize this. So by now, I do not have any visual available for the chat box. If you guys have any question, please use your microphone. All right, and let me see. Let me just find out my camera. All right, just give me 1 minute. All right, so because I'm going to start writing on the board, my face looks like really close to the computer. So I'm going to turn off my camera. All right, and I'm going to share this screen once again. All right, so let's zoom in. All right, so first of all, what we are going to discuss, how can we convert decimal notation into the scientific notation. All right, so have you guys ever attempt this? Do you guys know what is decimal notation and what is scientific notation?
No.
No, Professor.
Okay, no problem. No problem. So the decimal notation, right? It sounds like decimal point, right? Everybody must have heard that term, decimal point, right? Let's say if I give you this number, it has a decimal point. So this presentation of a number is called a decimal notation. Notation means just a presentation. If you have a number like this in which you have a decimal point, then it is called as a decimal notation. So it's very simple. Any number which has a decimal point, that presentation of that particular number is called decimal notation. What is scientific notation then? The scientific notation is a number in which you have a number or multiply by 10 to the power of something. You may have seen this kind of number like 1.8 times 10 to the power of 1, 2.6 times 10 to the power of -6, right? So if you see a number, a presentation of a number in one of this form, you can say this is called scientific notation. Scientific notation means the general form looks like this, where you have a number in front of it, then it's a multiplication, and then there is a 10 to the power of something. remember, when we had 10 to the power of something, it could be a two possibility. Either it could be a positive or it could be negative. When it is a positive, you don't need to put any sign in front of it. If it's 1, 2, 3, 4, 5, 15, you just say, write down the number 1, 2, 3, 4, 5, whatever it is. However, if you have a negative sign, you do need to present a negative sign in front of it, right? So if it's -6, -8, -15, you do mention the negative sign. So now you understand what is the decimal notation and scientific notation? Yeah.
Yes, Professor.
Right? It's just a scientific language, right? Otherwise, we can just keep it simple, and I'll try to keep it as simple as I can. Okay. So once you have a decimal notation, what you have to do in this exercise, you have to convert this into the scientific notation. So what is the rule? Let me just talk about the rule. The first of all, the first rule to write a scientific notation is decimal place must be after first non-zero digit. It means you have to move the decimal point wherever it is to a digit which is non-zero, right? After the first non-zero digit, it means if the number says 312.54, it means you have to move your decimal point from between 2 to 5 to between 3 to 1, right? That is the rule. So remember the rule. All right. Decimal place must be after the first non-zero digit. All right. That's what you have to do. The second, what should be the 10 to the power?
However many places you move.
Yes. So number of places you move, right? The number. So in here, when we talk about the 10 to the power, there are actually two concepts that we need to talk about. First is number, and the second is sign. Everybody agree? We have to put the number, that what should be the number, as you see here, right? And then you have to think about the sign. So the number is the number of places you move, number of decimal place. I'll just say DP, decimal place moved. All right. So if you're moving your decimal place to like two places, then it should be 2. If you're moving your decimal place 5 places, it should be 5. It's simple. Think about the sign. This is the part where everybody need a help, right? So what should be the sign for this number? So remember, if you're moving your decimal place from right to the left, let me just write down. This is right. You're moving to your left. The sign should be positive. All right. If you're doing opposite, if you're moving your decimal place from left to the right, then the sign should be negative. So as long as you remember this point, you should be able to answer this question very, very easily. Everybody follow this?
Yes, Professor.
Yes.
Great. If you guys have any question at all, please use your microphone and please ask me questions, okay? So in here,
Professor,
yes, go ahead.
can you please show us an example?
Yes, we are going to work on this problem, right?
Yes.
Yeah, we're going to solve both of this problem which you see on the screen. But before we solve that, we should know the rule, right? Or this, I would say like the steps, right? So we know the steps or the rule now. So what we're going to do, we're going to apply this rule to this problem. All right. So what we learned that the decimal place must be after the first non-zero digit. It means we're going to move this decimal place to between 3 and 1. So let's do that. So the final number should look like 1.254, right? What I did, I just moved the decimal place 2 places on the left, right? Or I can say after the first non-zero digit. Now we know the scientific notation must have a multiplication sign 10, and there must be something on top of the 10, right? Must be 10 to the power of something. What that should be? So let's talk about the second step or the second rule. For the number What number that should be? It is equal to the number of the decimal places we moved. How many places did we move our decimal place to?
2.
2, right? So we're gonna write 2 here. Yeah. Now, once we have the number, we're gonna think about the sign, right? What should be the sign? What we did, we move our decimal place from right to the left. Is it right?
Yes, positive.
Yeah, if it's
Positive.
right from the left, it should be positive. It means we don't have to write the sign. If it's a positive, we don't need to represent the sign. If it's a negative, we write the minus sign. So this is the final answer. And it is really simple as long as you know the steps. Yeah, make sense?
Yes.
So this is the
Professor.
final answer in which we converted decimal notation into the scientific notation. Awesome. Everybody's good following me? Yeah.
Yes,
Yep.
thank you.
Yes.
Yeah.
Great, great, great. Let's talk about the second example then, right? What is the first step? First step is we have to move our decimal place after the first non-zero digit. Non-zero digit means everybody understand that, right? This is 0, this is 0, this is 0. So anything other than 0 is called non-zero digit. When you have a decimal place here in this example, you have to move your decimal place between 2 and 5. Everybody agree?
Yes.
Right. Right? It means the number should be 2.54. Right? Now we
Yes.
know in the scientific notation, there must be a multiplication sign 10 and there must be 10 to the power of something. So let's follow the second step. What should be the number? As a 10 to the power?
3.
3.
We moved 3 places, so it should be 3. Excellent, good job. Right? And now let's talk about the sign. Which
Negative.
direction we move our
Negative.
decimal place?
Negative. 3.
Left to the right. Left to the right means the negative. Negative 3. That's it. Easy?
So far.
So far. That's all you have.
So
Right? So
far.
there is nothing more than this. I can
I
just
have a
give you more
question,
zeros.
Professor.
Sorry?
I have a question, please.
Go
So
ahead.
at the first question, we move 2 places, right, to the left. And
That's
at
right.
the second one, we move 3 places to the right. Why is it that the first one we move 2 places to the left and the second question we move 3 places to the right?
Because it's a rule. The first rule that we see here. Whenever you write a scientific notation, the decimal place must be means it has to be after the first non-zero digit. In here,
Okay.
if you see 3, 2, right, 3, 1, 2, 5, 4, this is your first non-zero digit. It means you must has to move your decimal place after this. In here, when you see the second example, the number 2 is your, like, this is your first non-zero digit. It means you must has to move your decimal place after the first non-zero digit.
Okay,
Yeah.
thank you. I got it. Yeah,
Excellent.
clear. Thank you.
Clear? Awesome. Awesome. Anyone else? All right. So let me see if I have, okay. So what I'm going to do, I'm going to give you a practice problem. All right. I'm going to keep this screen here so you guys can see the steps or the rule. And I'm going to ask you to convert this number. So let me just draw the box so you guys can stay focused on this number, right? 0.00000082. All right. In the exam, there is nothing more we can ask you other than giving you a longer number, right? Or a large number. All right. So if you guys can solve this, yeah, you should be able to do well in this concept in your classes too. All right. So I'm waiting for your reply. Okay. So I'm going to give you, I think 1 minute should be more than enough, right? So in 1 minute, you guys can reply what is your answer. Take your time.
Are we supposed to say it or write it?
Say it.
8.2
Times
10 to the negative
8.2 times 10,
10 to -6.
negative
Power
5.
-5, -6.
negative
6. No, -6. -6.
negative 6.
6, 6,
It's
6.
-6.
Negative 6.
It was a lot of zeros. No.
Out of 0, yeah. That's the trick, right? In the exam,
Yeah.
that's all you have to, pay attention to. The rules never change. It's just like, you just have to stay focused so you can count it correctly. That's it. There's nothing new we can ask you for, right? It just, we can ask you a longer, like larger number. We can give you so many zeros that, that is a trick, right? So now you know. All right. So I think everybody got it, got the answer by now. Give it a try. That's awesome. Let's just try to solve this as we know. So everybody know it should be the first step, or the first rule says we have to move our decimal place after the first non-zero. So it has to move it right after 8. So we can write 8.2. Now we know that it has to be multiplication sign 10 to the power, and there must be something in that 10 to the power, right? Let's find out what should be the number, right? How many places we move? So it's 1, 2, 3, 4, 5, and 6, right? In an exam, you can simply count it just like this, right? To make sure that you don't make a mistake, right? So you move it to 6th place. So we're gonna say 6, and we move it from left to the right. If it says left to the right, it should be a negative sign. So 8.2 times 10 to the power of -6. Awesome. If you guys get it right, awesome. If you haven't, now you know, right? Let me give you another one, the last one, before we move on. Anybody has any question?
No, thank you.
No.
No.
All right. All right. So 7, 6, 5, 0, 0, 0, 0, 0, 0, 0.0. All right. Give it a try. Keep in mind, the rule is still same. All right. You still have to follow the same steps, same rule.
Is it 7.65 times 10 to the 8th power?
We're going to find that out. You say 8, right? 10 to the power of 8. Let's see what everybody says, right?
I said
Yes.
7.
7.
I got 8.
7.65 times 10 to the 8th power.
8 or 7, right? So let's find out what is the right answer.
Isn't it 76.5?
No,
Eight
it
power.
should not be 76.5. As you can see, the first rule, what it says the decimal place must be after the first non-zero digit. In this case, the first non-zero digit is 7. So you have to bring your decimal place between 7 and 6. All right, I'm going to give you like 15 seconds extra to work on this, to double check your answer, and then we're going to solve this. All right, so as you guys know this by now, that it has to be after the first non-zero digit. So you're just going to say 7.65. Now it should be 10 to the multiplication of a number here, right? Let's find out how many places we move, right?
9.
We move 1, 2, 3, 4, 5, 6, 7, and 8, isn't it?
Yes, +8.
Right. So let's just, like, in case if you are kind of, if you find it tricky to count the number of 0, let's just do this, right? Let's keep it simple. Let's just do 1, 2, 3, 4, 5, 6, 7, and 8. This way you won't make a mistake and you can visually see it, right? So 8 is the right answer. That's right. Now we have to decide the sign. We moved our decimal place from right to the left. Right to the left is a positive sign. It means we don't need to represent it as a positive sign. So this is our final answer, 7.65 multiplied by 10 to the power of 8. Everybody's clear with this? Everybody understand this?
Yes.
Yes, Professor.
Yes.
Yes.
All right, so in the next slide, we are moving on. So if you have any question, please ask. If not, then we're gonna move on to the next one. Yeah. All right. Okay, so where is my, okay, so this, okay. Wash. All right, I couldn't see, okay, here. All right, so I had to erase this. Oops, just give me 1 minute, guys. My computer is acting up. Where is my clear button? All right, let's find out my clear. Oh. All right, where I can see the menu here. All right, I'm gonna stop sharing this. Sorry, guys. I should be able to see the menu on top. So this is here. Okay, where is my clear? Okay. All right, so zoom in. My apologies, guys. Why it's not coming up? All right, so stop sharing. When I zoom in, I'm not seeing this icon anymore. All right, so I'm gonna keep this. Share this. Here. Okay, this is close. All right. Okay, now I found it. Annotate and clear. All right, so let's move on. I had to close this. Okay, this is tricky. I think they have changed the functions. I used it last time when I was teaching the summer class. All right, let's go. All right, so sorry for that. Let's move on to the concept in which we are going to perform a reverse task, right? Instead of converting decimal notation into scientific notation, now we're going to convert the scientific into the decimal notation, right? So what are the rule and what do we have to do for that? So as you guys know what is decimal and scientific notation, it will be easier for you to answer this kind of question, right? The first thing is, if you have 7.86 times 10 to the power of 3, what should be the decimal notation should look like, right? So it means all you're going to do is whatever 10 to the powers you have, the number you have, right? You're gonna put that many, you're gonna move, right? This, so move decimal point to, let me just say X. If it's X, right? Move the decimal place to X places. right? If you have 10 to the power of 3, you're going to move your decimal point to 3 places. If you have 10 to the power of 5, you're going to move your decimal point to 5 places. If you have 15, you're going to move it 15 places, right? I'm just going to represent it as general, calling it 10 to the power of x. If it's x, it means x many times you have to move, right? Now, this is something you got to keep in mind. If it is a positive power, right? 10 to the power of positive and 10 to the power of negative. So this is where it gets kind of reversed. This is what you have to remember when you're doing scientific notation to decimal notation. If it's positive, it means you are going to move your decimal place from, okay, move to, I'm just going to say move to right. And if it's a negative, you're going to move your decimal place to the left. All right. Because we are doing a opposite task, we are going to move our decimal notation in an opposite direction, right? Again, if you have 10 to the positive power, we're going to move our decimal place to the right. If it's a negative power, we're going to move our decimal point to the left. Do you guys follow this?
Yes.
Yes.
Yes, sir.
All right, so these are the steps, or we can call these are the rule which you need to follow to solve this kind of problem, right? I'm just going to give you a simple example, right? Let's say if you have 6.1 times 10 to the power of 2, how are we going to solve this? We say the number, x number, right? What we have as a x, we have number 2. So we're going to move our decimal places to 2 places. But before we do that, we need to pay attention to the sign. What is the sign? There is no sign. It means it's a positive. If it's positive, it says we have to move it to the right. It means we're going to write down this. And instead of this, we're going to have to move it on the right side. How many places? 2 places. So we move our decimal place to 2 places. Do you follow this? What I did, I just write down this digit, right? 6.1. Decimal place was here. I am moving on the right because there's a positive sign. And because it says 2, I'm going to move it 2 places. So 1, which is right after, and 2. If it's that, it means there is no digit in between this, right? So what I'm going to say, this is the 0. And because I'm moving my decimal place here, I'm going to say 0.0. All right. So the answer for this question is 610. Or you can say just the decimal place here. All right. If you want to write down 0, you can write down that as well. Okay. Make sense?
Yes.
Yes, sir.
Everybody? Yeah.
Yeah.
All right. So
Yes. Yes.
awesome. Great. Great. So let's try this one. I show you the simple example, which has a less digit in the number, right? Now we have 3 digit in the number and 10 to the power is more than 2 too. So give it a try. I'm going to give you 1 minute to solve this. Follow this rule that we just have here. You should be able to answer it.
I have a question.
Yes, go ahead.
When you're writing the answer, do you have to put the 0.0?
No, you don't have to. Even if you in this one, right? When you, for example, if you just want to say 610, that is the right answer as well. All right, because we are like just learning the decimal notation, I just want to make sure that if you write 610, it means where is the decimal point? The decimal point is always after the last digit. This is what we just kind of assume, right? If I say 508, what does it mean? It means there must be a decimal point after that, right? So you can also write 610 only. You can also write decimal only, and you can also write 0 as well. just to understand this, that, okay, this is the decimal notation.
Okay, thank you.
No problem.
So it would be 7860
0. Yep.
points.
Point, yeah. So let's figure this out, right? To solve this problem, this is going to be our first step. We have to think about the sign. What sign we have? We have positive sign. It means we are moving the decimal place to the right. So what we're going to do, we're going to write down 7, 8, 6. And because we are moving our decimal place to the right, we're going to say from here to 1, 2, and 3. If there is nothing there, it means you're going to write 0 and we're going to put the decimal point here. So you can say 7860. This is also a right answer. You can also say 7860 point. This is also a right answer. Or you can say 7860.0. All right. We are going to talk about significant figure later on in this session. When we talk about that, I'm going to explain this to you, that this should be the correct presentation if we have to apply the significant figure rule as well, right? So sometime in the exam, your lecture professor or your lab professor like to ask you that question, that convert this scientific notation into the decimal notation and make sure that it has the same number of significant figure. At the moment, because we haven't talked about it, I don't want to imply that at the moment, right? But I just want to say that at the moment that this is the right answer if we have to have same number of significant figure. But in general, while we are just kind of trying to understand the concept, any of this presentation is the right answer. Okay.
Yes, thank you.
Yeah, no problem, no problem. All right, so let's try the second one. I hope everybody got it, right? Let's try the second one. Again, remember 10 to the positive power and negative power is something we have to consider first. All right, anybody has answered?
Yes.
Yeah.
All right, I think you guys put it down in the chat box. Okay, I can see now.
0.000474842.
Okay, so how many zeros you said?
3.
3 zeros. Okay. All right, so minimize this. I think my computer get freeze. All right, sorry. So yes, let's try this, right? What we have 10 to the negative power of 4. If it's a negative power, we gotta move it on the left side. So what we're going to do, we're just going to write down the whole number as we have, but we know the decimal place was here, right? We are moving to the left. How many places? 4 places. So we're gonna say 1, then 2, then 3, then 4. It means your decimal place must be here, and everything in between you have to put 0. So 1, 2, and 3 zeros, and that is also helpful when you present in this form, right? Because that way you know that you're going to put how many 0? 1, 2, and 3 zeros. So if you want to follow this technique, you can do that, right? You can do any other technique you like. This is something that I can think of that could be helpful, right? So your answer should be if I just want to rewrite that, 0.3047842, and this is the right answer.
Professor, we need to put that 0 after the decimal.
Yeah, I was about to ask that too.
We need to put the 0 after decimal. What do you mean?
You see,
You see the 0?
0 point, do we need that 0 there, or can it just be 0.000?
Yeah, you can definitely write 0.000. Sometime, you know, like when student answer this kind of question, the decimal point presentation is really like, you know, tiny dot. And many time, if your instructor cannot see that, he
Got
or
it.
she maybe, you know, mark it as a wrong. So it would be nice to have a big decimal point if you just want to represent it in this fashion, or you better just write the 0, right? Even if you write like 0.0004784, it is not the wrong answer. It is the right answer. But just
Okay.
make sure that you have a big visible decimal point.
Okay, thank you.
Yeah, everybody's good. Anybody has any other questions?
No.
No, Professor.
No? All right. So remember, the whole purpose of this workshop is to have a set of the rule, which you just need to practice and remember a little bit, and apply this when you are practicing on the problem, right? So we work on the rule and we work on the problem. So I think you should be, you can solve any number of the problem, right? As long as you follow this rule. So what we're gonna do, we're gonna move on from this, the scientific notation and the decimal notation, to the measurement and the unit conversion. So in this course, in general chemistry course, when we talk about different units, we talk about different measurement. There are a limit that we need to talk about, right? We are not going to talk about everything in this general chemistry course. We are going to mainly focus on the 5 measurement, which are generally called volume, length, mass, temperature, and the time, right? So these are the measurement we frequently talks about in this course. So I have kind of summarized them here. Volume, what is volume? Everybody know, right? If you talk about the milk of like gallon of a milk, right? Can of the soda, you know, like how many liter of the water, right? So those are called volume. What is the length? Everybody know it's a distance, right? The length is the distance or the how far the two ends are, right? Mass means the weight, right? In a simple word, we can say it's a weight. Temperature, I think everybody is familiar with it, and time also, right? What we have to do in this course is, as long as we know the measurement, we also need to know the different unit. If I talk about the different unit for the volume, you may have heard how we can measure the volume. We can measure the volume in the unit called liter. You may have heard that. When you talk about the milk, we may have used gallon. If you talk about the soda can, we may have used ounce, right? You have seen this kind of unit on the containers, right? On the household,
Yes, sir.
Yes.
right? Yeah, if we talk about like injection, it is generally in ml, right? So what we have to do, or what we need to learn in this course, is to be familiar with the measurement, first of all, then be familiar with different unit that we can measure this particular measurement into, and how we can convert one unit into the another one unit into another one. So if I say, for example, 1 gallon of milk, I don't understand that. Tell me how many ml of the milk you are talking about, right? So this is something what we need when we talk about, you know, like a inter-country, or, you know, like a between like a Europe and US, right? They like, if they are following the distance in kilometer or meter, and if we're talking about yard or mile, they won't understand what we are talking about. So there must be a conversion which help us to be on the same page, right? So that is what we are going to learn, right? That how we can convert the one unit into any of the unit we have, right? So just be familiar with this unit. Volume can be measured in liter, ml, gallon, and ounce. Like same with distance, right? Or length, we can say. It can be measured in mile, that we are more familiar with. If you're following like football, you may know that how many yards, right? In generally in Europe and Asia, the distance is been measured in kilometer and the meter, right? So there are different unit which we can measure the length into, right? Mass, what is mass generally measured in? If we talk about the pound of, pound of chicken, fish, 1 pound, right? We can talk about that. Again, basically in Asia and Europe, they may use grams and kilogram. Temperature, we all know we use degree Fahrenheit, and again in Europe they use degree Celsius. However, this is something new which you may not have heard before. If you have heard before, it's awesome. If you haven't, now you know it is a Kelvin. We use this unit very much in this course, so make sure you are familiar with this. Also, I want to point out one thing here, that whenever you talk about Celsius, you call it as a degree Celsius because you have a symbol in front of C. Same way for how many Fahrenheit, we always call it degree Fahrenheit because we have symbol in front of F. However, every time when we call it as a Kelvin, we don't call it degree Kelvin. It is simply Kelvin. Remember this. Okay, so this is the unit which we use the most of the time in this course. In the exam, what happened is generally the unit is given in the Fahrenheit or degree Celsius. What do you have to do? You have to convert that into the Kelvin before you solve the problem. All right, so I'm going to share all those formula that you need to know to convert this unit into another one. Time, I think everybody are familiar with it, second, minute, and hour, right? So what we're going to talk about, we are going to talk about different units, what is that relation between, and how we can use that relation to convert one unit into another one. All right, so this was like just to give you an introduction. If you have my handout with you, right, or if you just want to look at it at a PowerPoint slide right now, it's fine. These are the most commonly used unit conversion. It means when I say 1 liter, I don't understand. Can you tell me how many gallon it is? So what we're going to do for that right now, because it's all advanced, we already know the relation that 1 liter is equal to this many gallons, right? We already know that 1 kilometer or 1 kilogram is equal to this many meter or this many pounds. So these are the most commonly used unit conversion that you have on this screen. For time, I think everybody is familiar with it. 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds. Same way for the length and distance, we can have this unit conversion. 1 feet is equal to 12 inch, 1 meter is equal to 39.4 inch, 1 inch is equal to 2.54 centimeter, 1 kilometer is equal to 0.621 miles. Remember this, right? What I mean to say is you don't have to remember this, right? You just need to keep this handy, right? These are the unit conversion which should be given to you by your lecture professor or lab professor. If it's an online exam, you're supposed to keep it handy. All right, so you don't have to memorize any of this. I'm going to tell you which one you have to memorize. All right, but at the moment, whatever you're seeing on the screen, which is all of them, you don't have to remember, right? Just keep that handy and be sure that you know how to use this information to solve the problem. I did not talk about another measurement which we have, which we are going to talk about a lot in this course is energy. We do talk about energy quite often in this course, and there are 2 units for energy. What are they? Calorie and joule. And what is the relation between them? The relation is 1 calorie is equal to 4.184 joule. Again, this is not something you have to remember. It will be given to you. All right. If it's not given to you and if it's online exam, you're supposed to keep it handy with you. All right. You do need to remember one of the conversion on this screen is this, which is an easier number. Again, I don't want to focus on these numbers a lot at the moment because when you learn more theory part of this course, you will understand it better. However, I just want to point out this, that the relation is between capital C calorie and small c calorie, right? So you see, this is the small c and this is the capital C. So if anybody gonna ask you 1 capital calorie is equal to how many small c calorie, here you just call it as 1,000. 1,000 is, again, it's not a number that is hard to remember, and so many time exam instructor like to ask this kind of question. So if you guys can remember this, or if you guys kind of have this print out and put it in your on your study desk, it will be great. When you repeat this information in your mind, or if you keep reading this, you will be able to remember this. But other than this, nothing on this screen that you have to remember. Just be familiar with this number so we can use it when we need it. All right, so anybody has any question? So far so good?
Yep, perfect.
Great,
Okay.
thank you.
Yes.
Yeah, awesome. All right, so what we're going to do, we are going to start with this easier problem, right? And then we're going to work on something more important and more kind of challenging. At the moment, if I'm going to ask you 1.7 hours is equal to how many minutes? I think it's not a hard question to find out the answer for. I'm going to let you find out the answer. However, remember, when we take the exam, you have to show your calculation, right? If you put it in a calculator, if you find out the answer, it's not enough. You have to show how did you find out that number. So make sure you write down the steps that how did you get to your answer. All right, so again, I'm asking you this. Let's do this problem. I'm going to give you 1 minute to solve this. 1.7 hour is equal to how many minutes? I believe everybody know the relation between hour and the minute. 1 hour is equal to 60 minutes, right? Use this information to answer this question.
Is it 67 minutes?
67,
I got 102.
102. Take your time. 102. Right, I can open the chat. Looks like most of you guys are saying 102. All right. Can we work on this now? Yeah.
Yes.
Yeah. All right. So I already I do respect the method that you follow, and this is the math. There are many ways to solve the problem, and you can follow any method you like. Again, the purpose of this workshop is to make sure that I try to share easiest method that you can apply in the most of this problem solving, right? To be able to answer this question very, very easily. So what I'm going to do, I'm just going to share how you can attempt to solve this kind of problem. Again, this is unit conversion, which you can see here that the question was given in the quantity of hour, in the unit of hour, and what it has been asked you to do is convert this unit into this. Oops, okay. I think I moved the question to the next one. Sorry, my bad. All right. 1.7 hour is been given to you, and I am asking you to convert that into the minutes. To do that, what you have to do for every unit conversion problem, what you need to do, you need to have this relation, and this is called equality factor, because it says equal value, right? Either you call it 1 hour or you call it 60 minutes, its value is the same. That's why it's called equality factor. You can also call this as a conversion factor. Why? Because we can use this to convert conversion factor, because we can use this to convert the quantity given in hour into the minute, or quantity given in a minute into the hour. Right now, remember, every time when you have this equality factor, there are two ways you can write this to solve the problem. What are the two ways? Very simple. You can put any one on the top. In this case, we are putting 1 hour on the numerator and 60 minutes at the bottom, or we can say denominator, right? Either you can use this form, which is, I'm going to call it A, or you can write this down in this fashion in which you're putting minute on the top. You can use any of this form to solve the problem. All right. So every time when you have unit conversion problem, first thing what you do, first step, write down the given quantity, whatever number is given to you, write that down along with the unit, right? So what I'm going to do here, I'm going to write down 1.7. I'm going to say H means hour. Now the second step is multiply with a, I would say, appropriate form of a conversion factor. So as I just mentioned on the side, there are two ways we can write the conversion factor. First of all, we need to have the equality factor. Either it is given to you or you need to find out, right? That's the first point. Once you have the equality factor, you should be able to understand this, that either you can write this equality factor in this conversion factor, in which we are putting hour on the top and minute on the bottom, or you can write down in the B form, in which we are putting minute on the top or hour at the bottom. Either form you want to use, which one you're going to use, it depends on what information is given to you, what is here. In this case, because 1.7 hour has been given to you, what you're going to do as a second step, you're going to multiply and write down one of the conversion factor, either A or B. The one that we're going to pick is, we're going to pick B is the one we're going to pick. It's a 1 hour and 60 minutes on the top. I'm going to explain you the reason in a minute. Why do we do that? Remember, this is a unit conversion problem in which we're supposed to cancel out the given unit and convert that into the unit we ask for. To cancel out the given unit, what we have to do, we have to have the same unit, which is here. It has to be in a denominator, right? We have to have the same unit in the denominator. That is the whole purpose. As long as you keep it in this form, you are getting in the right direction. You are going to get the right answer. That's it. The whole purpose of the unit conversion is to cancel out the given unit. In order to cancel the unit, you have to have the given unit in a denominator. So that is the reason why I use form B. Because if I use form B, it says hour at the bottom. If I put hour at the bottom, I should be able to cancel out hour on the top and on the bottom from the numerator and the denominator. Now, if I do the math, what numbers I have? If I just simplify this, I have 1.7 multiplied by 60 minutes, right? If you, and I do not have anything else. If you just want to put 1 underneath it, it's fine, but 1 doesn't change any answer. So if you solve this problem, your answer could be around 1 or 2. Is it right?
Correct.
Yes.
Yeah. So
Yes,
I
Professor.
know you must have done the math any way you like, and that is completely fine. All I'm saying is, if you can follow this method for any unit conversion problem, it will definitely work. And the goal is to cancel the given unit. To cancel the given unit, all you have to do is put the same unit in a denominator so that you can cancel this out. When you can cancel this out, it means your final answer must be in a different unit, right? And this is the answer that we wanted. So yes, we got our answer. For example, right? if in case of this, if I'm gonna give you, okay, I don't have space, but I'm gonna write that. And I'm gonna just squeeze some information here. Instead of giving you 1.7 hour, let's see if I'm giving you 160 minutes. And I am, instead of asking you in minute, I am asking you in hour. What are you going to do? Let's give it a try, right? So I'm gonna just show you this method so you guys can remember this for hour, and you won't find this anymore like hard anymore. You're gonna write down what is given to you. That is the first step. What I say, write down the given quantity along with the unit. 160 minutes is given to you as a part of the question. You're gonna write this down. Then second step, multiply with the appropriate version of the conversion factor. It means you're gonna multiply and you're gonna use the conversion factor. When we call it conversion factor, it means something on the top, something in the denominator, or something in the bottom, right? Let's think about it. What is the purpose? To cancel out the given unit. In order to cancel out the given unit, if I'm going to ask you, are we going to use form A or form B to solve this problem? What should be your answer?
Form
A.
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 Excellent. Did everybody understand this?
Yes.
Everyone? Yeah. Yeah. Awesome. The reason is because we want to cancel out the given unit, we're going to put the minutes on the bottom. So either we are using our A or B, it depends on what is given to us. If hour has been given to you, then you're going to put the hour in the bottom. If minute has been given to you, you're going to put the minute in the bottom, right? What are we going to have? Minute. What do we have in front of minute? 60. So we're going to put 60. What we have on top? 1 hour. So we're going to say 1 hour. Now what we see, you can cancel out the given unit, which is minute on the numerator and the minute on the denominator. So if you simplify this, your math looks like this: 160 multiplied by 1 hour over 60. You don't have any more unit. So if you just simply multiply this, you can have your final answer in hour. I'm going to let you do the math, and please let me know what is your answer.
Professor, I know you said that later we're going to be doing significant figures, but for these examples, what decimal point should we round to?
When we're going to talk about the significant figure, I will definitely explain you this. However, at the moment, we can have three significant, okay, I gave you a real number. Okay, I think I should have given, at the moment, it should be two significant figure. It means
Okay, thank you.
it should be only 2 digit. Yeah. And I'm gonna explain you why. Okay. So what should be your answer, guys?
2.6.
2.6, right? Excellent. So the whole purpose of this kind of exercise is to understand that there are two ways to write the conversion factor, but which one you are going to use, it always depend on what is given to you. All right, is this clear to everybody?
No, I'm sorry. So specifically, what was multiplied to get to 2.6?
It is this 160 multiplied by 1. So again, it's 160. Then whatever your answer is, you're gonna divide that by 60. So which you see here.
6.
Yeah, so 160 multiplied by 1 divided by 60 is going to give you the answer of 2.6.
Thank you.
Yeah. Anyone else? Any question? Any confusion? All right. So let's move on from this simple problem into a little bit more challenging, right? Let's solve this. I am still giving you kind of same numbers, but instead of asking you to convert hour into minute, I am asking you to convert that in, I'm asking you to do that into seconds. All right. Again, you can follow any way you like. Give me the answer after 1 minute. And then I'm going to show you my method, right? I'm still following the same method, which I show you, but this is going to be little, like maybe one extra step. All right, I'm going to give you 1 minute to solve this problem. All right, so I see you already, like, I can see the chat. You guys already started putting your answer down there. All right, awesome. I'm still gonna give you like 30 more seconds. I know it's like 2-step conversion, so you may need more time. 30 more seconds, and then we're gonna discuss, okay? All right.
I think we're ready now.
Yes, definitely. All right, so I'm going to show you the method that I like you to follow if you like to, right? So what we have our, oops, what happened? All right, so we have our, and what we had to do is, I don't want to write 1 hour. We have hour and we have to convert that into seconds. All right, so to do that, what we need to know what is the relation between hour and the second. Does anybody know 1 hour is equal to how many seconds?
60.
3,600.
3,600 seconds. If you know that, it's excellent. If you don't know, it's okay. What we can understand is we can say 1 hour is equal to 60 minutes, and that's not wrong, right? We know that this is right. Now, is this the final answer we want? No, we don't want our answer in minute. We want our answer in second. So what we have to do, we have to think about what is the relation between minute and the second. And what we know, 1 minute is equal to 60 seconds. Right? So instead of just using one conversion, what we're going to do, we're going to use 2 conversions. So this is your first equality factor. This is your second equality factor. We're going to use this one first, right? Again, you guys can understand this, I hope. 1 hour over 60 minutes. You can write this way, or you can say 60 minutes over 1 hour. The same way you can write this in 2 fashion. You can say 1 minute over 60 seconds, or you can say 60 seconds over 1 minute. All right, so whenever we are solving the problem, what did I say? Always write down what is given to you. 1.7 hour is given to you. In a unit conversion problem, we're gonna multiply with one of the conversion factor. Now my question is, I'm gonna label them as A, B, C, and D. Now I'm gonna ask you, which conversion factor are we going to apply here? Can you guys answer that?
D.
B.
D.
Anyone else?
You're gonna put B.
Excellent, right? We are going to put the B. Why? Because that's the only one in which we have hour at the bottom. So we put 1 hour and 60 minutes on the top. So we use the conversion B, right? In this way, we can cancel out the hour. If we do the math, which we already did, what was the answer? 1 or 2, right? 1 or 2 minutes. Right? We got our answer. However, this is not our final answer because the question asks us to find out answer in the seconds. So what we're going to do, this answer, we're going to use this again and keep on going, right? So we have 1 or 2 minutes. So we're going to write that down. Again, we're going to use another conversion. Why? Because it wasn't our final answer. Now my question is, which conversion factor are we going to use at this point?
D.
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 Good job, right? We're gonna use D. In why? Because it is the only one which has minutes at the bottom, right? And we have seconds on the top. If we cancel out the minutes, we have seconds as a unit. Let's just do the math. If I just simplify this, it says 102 times 60 seconds is equal to how many seconds?
6,120 seconds.
6,120 seconds. And that was your answer too. And I know you may have done the math differently. However, I'm just showing you the steps which you can apply to solve any of the measurement that we talked about for the unit conversion, right? If you have to do the unit conversion for any of those measurement we talked about, you can apply this. All right, so that's the good use. That's the like a best strategy that I find. You can just follow the universal steps for anything, nothing that is you have to remember. That would be awesome. All right, so this is what you have to do. So just remember, instead of having one conversion step, you can have 2 or 3 conversion steps. However, you are still following the same steps, right? So it's nothing new. We are just kind of, instead of one step, we are doing 2 steps, right? But we still follow the same method. So I hope this is helpful. Anybody has any question from this?
No.
Yes. Could we merge those two formulas into one, right?
Yes, you can definitely put those two in one.
Okay.
Yeah. So if I just have to show you that way, you can just write down. Okay, I'm going to show you that in the next example, right? Instead of just repeating this information, I'm going to show you how we can put all this information in one step and you can get your answer. All right. Any other questions? All right. So what I have done here, because I know that we haven't learned about the unit conversion from pound to the gram. What I have done, I have given you the unit conversion, right? Which I told you that this unit conversion will be given to you. I have given you the both equality factor, and the question is right here. It says 2.54 lb means pound, right? Which you can see here. lb is the presentation or is a symbol for pound, equal to how many g? G means gram. All right, we just solve a similar problem. Now I am just giving you maybe like 3 minutes to work on this, right? I gave you the equality factor. Try to understand which kind of conversion factor you're going to use. Apply the something that we just learned and try to give me the answer, right? I'm going to give you 3 minutes to solve this. All right. So can I just show you the steps now? Yeah.
Yeah.
All right. If you're still trying, keep on working. Okay. All right. So as you guys know by now, the first thing is to write down what is given to you along with the unit. So I'm going to write this down first. Now I'm going to use one of the conversion factor in which the pound is at the bottom. Right now, if you look at this equality factor 1 and 2, you can see there is a first equality factor which shows the relation between kilogram and the pound, and there is another equality factor which shows the relation between pound and the gram. Do you have to use both of this or just one of it? That is going to be my question.
Just one of it.
You can just use number 2.
Excellent, right? That was the purpose why I gave you two of them, right? Because I want you to understand that when you have so like all the unit conversion available to you, you have to figure out which one you are going to actually use depending on kind of question has been asked. In this question, all you have to do is convert this pound into the gram. If you look at the second conversion factor, we have the pound and we have the gram. It means simply by using the conversion factor number 2, you should be able to answer the question. In which, let's say if once we know that we are going to use the second number equality factor, we are going to put the LB or pound in the denominator so that we can cancel out the given unit. In this case, the number in front of LB is 1, so I'm going to say 1. And the other side of this equality factor goes on the top. So instead of just representing in this form, I'm just going to write down in here. All right. So this way, I cancel out the LB. And if we just simply do the math, your answer was, what did you write? 1153.16 gram. Yeah.
Yeah.
Yep.
All right. Everybody got this?
Yes, sir.
All right.
Yes.
Excellent. Excellent. All right. So we can move on from this now. So now we talk about the unit conversion, and we talk about the unit conversion which should be given to you. At this, starting from this point, we are talking about the unit conversion which you should remember, and that actually we call as a prefix. So what is prefix? So if we use liter, for example, right? If we already know there is another unit called milliliter, ml, right? You may have heard microliter, or let's say if you talk about meter, you may have heard the unit kilometer. So in all of this, what we can say, this is the basic unit. Liter is the basic unit, meter is the basic unit. Anything we use in front of it, which is milliliter in this case, microliter in this case, and kilometer in this case. So what are this? Milli, micro, kilo. What do we call that? We call it as a prefix which we use in front of this different unit. All right, make sense? Yeah.
Yes, sir.
Yes.
We have
Yes.
basically two tables. Thank you, guys. We have basically two tables in which we have to remember the name of the prefix and the value for those, right? What are those? So in this course, basically you don't have to remember the last two. If you can, or if you like to, it would be awesome, great. However, in general, in the exam, they generally ask you from one of this. All right, so I'm just going to point this out at the moment, something to remember. Right, this won't be given to you. You have to remember the value. Before we remember the value, let's just talk about this. What are the prefix called? The prefix is deci, centi, milli, micro, and nano. So these are the name of the prefix. What is the symbol for them? So deci, it means small d, centi means small c, milli means small m, micro is like a U, but extra, like a tail, I would say like trunk to it. All right, micro. And nano is small n. All of these symbols are small later. What it indicate? It indicate that whenever you use this prefix, it is a smaller value. What do I mean by that? So let me just give you a simple. So in any of this unit, you can use like centi, right? You can use in front of meter, which you are more familiar with. Centimeter, we talk about it so many times, right? If we talk about milli, we use mostly in front of liter. We also use millimeter, right? So what we're going to do, we are going to find out the relation between this prefix and the original unit, which in this case, generally we talk about volume, then it's liter. If we talk about distance, is meter. If we talk about mass, then it's a gram, right? You follow this? So we can use all of this prefix which we have in this table in front of this commonly used unit. Now let's talk about what is the relation. So when we call it 1 decimeter, I'm just going to use meter for all of these prefixes to help you understand this. It equal to 10 to the power of -1 meter. All right, so when we talk about 1 decimeter is equal to 10 to the power of -10, 10 to the power of -1 meter. If we talk about 1 centimeter, then it's equal to 10 to the power of -2 meter. I think it's simple, right? -1, -2. Then if we talk about 1 millimeter, then we can say it is equal to 10 to the power of -3 meter, which is again -1, 2, 3. It's not that hard to remember. Now, when we talk about the remaining two, there is an increment of 3. What I mean by that? If we use 1 micrometer, it means 10 to the power of -6 meter. And if we use 1 nanometer, it is equal to 10 to the power of -9 meter. All right, so you start from -1, then it's -2, then -3. Once you reach to -3, then there is increment of -3, right? So -3, -6, and -9. All right, so this is the way you can remember the prefixes. Again, remember this, all of these prefixes has a small letter symbol, right? So instead of writing this decimeter, we can say DC. Instead of writing centimeter, we can say CM. Sorry, my bad. DM, my bad. DM, CM, right? MM. Micro would be like mu m, and nano would be nm. All right, because it is a lower symbol, right? It means it's a smaller value. What I mean by smaller value, it means it should be 10 to the power of negative sign. So -1, -2, -3, -6, and -9. All right, I just want you to understand this. It is not just a meter where you can apply this prefix. You can also apply all of these prefixes in front of liter or in front of gram. So you can also call 1 milligram, it is equal to 10 to the power of -3 gram. You can say 1 milliliter is equal to 10 to the power of -3 liter. Do you guys understand this?
Yes.
Yes, sir.
Yeah. So this is the part which you have to remember for this course, right? Of course, you have like enough time before the first exam. So, and anyway, when you are attending this workshop, you are already ahead of the other students. So you can spend some time on working on this, and eventually it comes naturally, right? So you don't have to put like a lot of effort, but yes, there is some memorization for this. Right? The same way, if we talk about the pico and femto, as I just say, it goes up by 10 to the power of 3. So it's going to be -12 and -15, right? So it's not that hard to remember. However, most of the time, because this is introductory level chemistry class, we don't ask you this, right? Can we move on from this? Everybody good?
Yes.
Yes, good.
Yeah.
Yes.
Awesome. Awesome. As I told you, it's not just one table, that is a two table, but this one is going to be easy, right? Because we have less numbers and less prefixes. All right, so in the previous table, every prefix that you know has a smaller symbol, represent a smaller value. This is opposite. In this case, except the kilo, all of this has a first letter symbol, right? It's or we can say capital letter, right? What it indicate, it help you to understand that all of these prefixes has a greater or higher value than the original unit. Again, what are those? So in this case, we can remember it from bottom to the top, would be easy for us, right? Kilo, the first one is goes as a kilo. Kilo is the only one which has a small k, right? And symbol would be small k, right? Kilo. Then is mega. Mega is capital M. So remember, when you see, this is something we know where people or students get confused. If you see small m and m, it means millimeter. If you see capital M and small m, then you should be able to understand this. This is megameter, right? So because there are two m, one is capital and the second one is like small m, you have to keep that in mind. All right, so in the exam, if you see a symbol, please spend maybe like extra 5 seconds to understand that before you work on the problem. All right, so this is megameter, or we can say mega. Then it's a giga. Giga is G. Again, the tera and peta is not everybody use that often. All right, so for this course, I would say these are the three most commonly used. However, if you just want to remember one more, tera is not that bad. Is this. Now these are the easier to remember. Again, how? Because this kilo means 10 to the power of plus 3. Mega means 10 to the power of plus 6. Giga means 10 to the power of plus 9. Tera means 10 to the power of plus 12. So this is all, this starts with the number 3, 10 to the power of 3, and then goes up by the additional 3, right? 3, 6, 9, 12. All right. So this could be easier to remember compared to the previous one, right? Previous one start with -1, -2, -3, and then it start with -6, and then it's followed by -6 and 9. And here we just have all the positive number start with 3. So 3, 6, 9, and 12. Again, as you can see, all of this has a capital symbol, right? It means they are going to have a positive sign. As I just discussed that earlier, all of this prefix can be applied to any unit that we talk about. It can be applied to liter, it can be applied to the meter, and can apply to gram. So we can say this many kilogram, we can say this many mega meter, we can say this many giga liter, right? We can call it any way you like. Okay, do you guys follow this?
Yes.
Yes, sir.
Yes,
Yeah.
thank you.
Awesome, awesome. And just in case, if you are like, I think most of you guys are using a smartphone now, right? So if you just want to be kind of more familiar with the storage of your phone, you may have heard like, or you have may seen this KB, right? MB and GB and TB. Sorry, not small, capital. My bad. And the B should be capital as well. Sorry, my bad. So KB, MB, GB, and TB, right? So just want to give you an kind of really easier way to understand. B is the one of the unit called bytes, and K means kilo. So if you use any, if you just have like a word file or your notes, and if you look at the memory, it is in the kilobytes because it's small values, right? Bytes is the unit for the storage. If you take the picture in your phone, and if you look at the memory, how much memory it takes, it's generally in MB if you're using smartphone, depending on kind of phone you're using. But most of the smartphone has a larger memory in the phone because you have like more clarity into the pictures, right? It should be MB. when you talk about the speed of your phone or your laptop, you may have heard that how many GB, that, oh, it's 128 GB. This is 64 GB. What is that? GB means, again, gigabytes. And if you're really, kind of technology fan, you may have had like a external hard drive. Right? If it's external hard drive, now we know that is a terabyte. It means it's a really huge memory, right? So this is also like something you can kind of connect to if you are like more like a technology fan, to remember the order: kilo, mega, giga, and tera. Right? Just something to help you understand. All right, sounds good.
Yes.
Yes, sir. I just learned something new.
Yeah, awesome. Awesome, great. All right, so moving on from this, what we're going to do now, we are going to solve the problem using the information that we just saw, right? I know that you may not remember this value. So what I'm going to do, I'm going to give you the conversion factors. However, the problem is the similar, like we are going to solve the problem similar way that we solve earlier problems. What it says in this question, it says 4.50 milliliter equals to how many nanoliters. I know you need more time to process these symbols and remember the values. It's completely fine, but I do want you to understand, like I do want you to give it a try. So I'm going to give you the conversion factor. Now if we talk about this, right, if you are really good in math, you can definitely find out the direct relation, just the way somebody did earlier. For 1 hour is equal to how many seconds. If you know the direct relation, you can use that. If not, it's okay, right? You don't have to be like, no, you don't have to know everything, right? It's fine as long as you know the basics. What is the basic? We know when we use ml, there must be a relationship between ml and liter, right? There must be a relationship between the prefix and the original unit. The same way, there must be another relationship between nanoliter and liter. As long as we can able to find out these two relationship, right, we should be able to solve this problem by using two-step conversion. So first of all, what is the relation between ml and liter? Like I know it's too early for me to ask you, but just wondering if anybody remember what is the value for milli. This is a milli.
Milli is 10 to the negative 3.
Excellent, excellent, right? Great job. Again, it's too early, I know that. If you can remember it, it's great. Eventually, yes, go ahead.
Did you want your answer in the scientific or in the decimal point?
You can give me in a decimal point, it's fine, right? Okay. All right, so what was the relation? 1 milliliter is equal to 10 to the power of minus 3 liter. Okay, so now we know this is the relation, right? Eventually you will practice it, you will remember this. Again, the next one, 1 nanoliter is equal to how many liter? If you remember that, it's great. If you can't, it's okay. It is minus 9. All right, so instead of giving you the conversion factors in the exam, this is something you have to know, right? Because we are practicing on this, I gave you this right now. All right, so let's do one thing. I'm gonna let you work on this problem for maybe like, I think 3 minutes should be enough. All right, and let me know what is your final answer. And I couldn't see somebody who asked me just what kind of answer I want. Even if you write the scientific notation, because I see that it's going to be like easier to write in a scientific notation, you can have your answer in scientific notation. That will be more easier for you to kind of do. All right, so please give it a try. Follow any method you like. If you like to follow the method that I show you, it will be great. After 3 minutes, I'm going to show you the solution. Yeah, so work on this problem for 3 minutes. 12:48. All right. So it would be awesome if you have given it a try. If you haven't got the answer yet, it's fine. What we're gonna do, I'm just gonna show you the steps. I hope you guys understand this by now, right? So let's talk about this. As you guys know, I have mentioned it a couple of times by now that first of all, we are just going to write down what is given to us. So 4.50 ml. I'm gonna write that first. Now, as you guys know, in the conversion factor, which one are we gonna use? The first one or the second one? Which one are you gonna use?
The first one.
First one.
First one.
Great. And if you're gonna use the first one, which side of this equal sign goes in a denominator?
The
Right.
ML.
This one goes in a denominator, right? Because we want to cancel out the given unit, we're gonna put the ml at the bottom. So this side goes in a bottom. It means this side goes on the top, -3 liter. If I cancel this unit out, I will have my final answer, which is, I wouldn't say final answer, I would have my answer as 4.50 multiplied by 10 to the power of -3 liter. I didn't do any simplification. Why? Because this is not my final answer. I want my final answer as a nanoliter. I got my unit as a liter as of now. So this is not my final answer. What does it mean? It means it's a two-step conversion where I'm just going to continue with the answer I got in the first step and use another conversion. Now in the second conversion, please tell me, left or right side of this equality factor goes in a denominator? Left or right? Which one goes in a denominator?
Right.
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 Good job, guys, right? 10 to the power of -9 liter goes at the bottom or denominator, and 1 NL goes on the top. By doing that, again, we cancel out the unit we had, and we will have our final answer in nanoliter. Now, do you guys know how to plug in this value in your calculator? If you know, it's great. If you don't know, what I'm going to do is you can stay for, like after 1 p.m. you can just stay online, and I can show you how to plug this in your calculator, right? All you have to do is just put it in your calculator and find out your final answer, right? Do you want me to show it right now? Are you guys good?
Sure, you can
Sure.
go ahead.
Oh, no, please.
Sorry, I couldn't understand any of you guys.
Yes, please show it now.
Just show it to us.
Yes,
All right,
please.
great.
Thank you.
Great, now show you now. Okay, great. All right, so I had stopped sharing this. Okay. All right, so are you guys using your cell phone? Most of you guys, yes? Or
I'm using a calculator.
Calculator.
calculator? Awesome. All right, so what I would ask you to do, I would ask you to plug in this way, right? 4.50, then multiply, then, all right, so you have 10x button. Do you guys have this button?
Yes. Yeah.
Yeah. All right, awesome. Then you press the 10x button, then you press the bracket. All right, then you press minus. All right, plus or minus, I would say. Then you press 3. You close the bracket. You press the divide sign. Again, you press the 10 to the power of x button. You press the bracket, plus or minus sign. Then it's 9. Close the bracket and press the equal. All right, these are the key which you have to use in your calculator.
What if I'm using the phone and I don't have a 10x?
All right, so let me see. If you're using your phone, do you have x to the power of y key? Do you have this?
Yes, sir.
right? So what you can do, you can, so let me just write this down. So you can press 10, right? So just forget about this. 4.50, then multiply, then you press X, okay, then you press 10, then you press X to the Y key, and then you press plus or minus, then 3, and then close the bracket. So instead of just using 10 to the power of X key, you are pressing 2 keys. All right, give it a try. And anybody using this calculator, did you guys get the answer?
Oh, is it 0.0045?
0.0045 minus 6. It should be a larger number. All right, so just give me 1 minute. It should be plus 9. So it should be plus 6. No, the final answer should be 4. Okay. 4. You may see something like this. All right, 2 here. 0. 1, 2, 3, 4, 5, 6. This is the final answer, or you may write down as this times 10 to the power of 6. Right? Either you can write down, okay, 1, 2, 3, 4, 5, 6. So this is the answer. 4, 5, and there is 5 zeros, or you can say 4.5 multiplied by 10 to the power of 6. Now, guys, can you please let me know if you guys get this right answer using the first formula which I show you here?
I did it
I got
differently.
it.
You got it? Got it? So that works if you have the
Got it.
Got it? Oh, excellent. Good, great, great. And anybody who is using your cell phone, the only change for you is instead of pressing this 10 to the power of X key, you're pressing 2 keys, which is 10 followed by X to the power of Y. All right. So at the moment, what I would say, just take the picture of these steps, right? Give it a try when you have time. If you can get the right answer, I can help you later on, right? Because we need to move on. So please take the picture. I'm going to give you 15 seconds. Take the picture of the screen. You can give it a try later on.
Hello, Professor.
Yes.
So is the answer 4.50 times 10 to the negative 12?
No, this is the answer which I show you here.
I'm sorry. So it's a 4.5 times 10 to the 6th power?
Yes. Or you can write down in a decimal notation, which would be like 4, 5, and there is 5 zeros. Yeah.
Because I know when you're multiplying decimal points, you have to add the exponents or something like that.
Oh, you know that? That would be great. Yeah. Then I can show. I can maybe like
yeah.
After 1 PM, I can show you the method how you can use that method. Yeah.
Yeah, because because there's a -3, and then when you add -3 plus -9, since I thought it would be -12.
Yeah, but because you have -9 at the denominator, so when it goes in a numerator, it becomes +9. So that is the difference. So I don't want to confuse everyone and you too. So if you want to understand that method, I can definitely explain you after 1 PM. Sounds good?
Okay, thank you.
Yeah, no worries. All right, so please give it a try. It's all about using your calculator, right? So at the moment, if you're not familiar with your calculator, it's fine. Take your time. You should be able to answer this question. Like you should be able to figure out how to use it correctly, right? And that is the whole purpose of this workshop, right? That way you kind of understand it before you actually start your classes. So that's great. Again, if you guys need help, I'm always here, right? I'll be happy to kind of answer your questions later on, right? So let's move on. All right, what I want you to do, like I want you to work on this problem on your own time, right? And you can share your answers in tomorrow's workshop, right? Or tomorrow's session. So again, take the picture of this, because I do want you to want to cover a significant figure, right? So take the picture of this, consider this as like a homework. You already have all the unit that you need. Give it a try and let's see if it can work, right? If it doesn't work, I'm always here to help you out. We can work on this problem tomorrow. All right, but please take the picture and work on this when you have time later on today. For this, again, I'm going to give you 15 seconds. When you're done taking picture, we're going to move on. Okay.
Done.
Done. Awesome. All right. Done. Done. Great. All right. All right. So significant figure. This is really important concept and really easy as long as you stick to the words that I have here. All right. I try to keep it really simple. First rule, what is significant figure means? First of all, significant figure means, let's say when you come up to the answer, right? Like say 6.1, sorry, 6.1, 2, 3, 4, 5, 6. If you see something like this in your calculator, are you going to plug in, are you going to write down all this digit in your answer? You're not sure, right? Sometimes you just kind of cut off the last 4, sometimes you just cut off the last 3, sometimes you just cut off the all of them, like maybe like last 5 or something like that. That is not how it works, right? Actually, when we talk about chemistry, we have to be consistent in the answer, right? And that's where the significant figure rules comes in. Significant figure, it simply means that how many digit that should be in your answer, or that should be in the number, right? If you have something like this, right, 6.123, how many digit do you have? You have 1, 2, 3, 4. There are 4 digit. It means there are 4 significant figure, right? So simply counting a digit refer as a significant figure. However, not all the digit are considered as significant figure. So what we're going to talk about, we are going to talk about 3 scenarios where we are not going to consider, or I would say like 2 scenarios where we are not going to consider 0 as a significant figure. If we are following this rule, or if the number or the given number is following the rule, then all those 0 you are not going to count as significant figure. If the number is not following one of this rule, then those 0 will be counted as significant figure. All right, I'm going to give you the example tomorrow, right? Probably we can't take it today, but I do want you to understand the rules. The first rule, it says if the number is less than 1. So number has to be less than 1. Less than 1 means what? It could be 0.0123, 0.123, something like this, right? Which has 0 point something. It means less than 1. Then it says if the number is less than 1, then it says all the zeros, no matter how many you have, before your first non-zero digit. It means in this case, you have your first non-zero digit is right here. In the second example, you have your first non-zero digit right here. It says all the 0 before that first non-zero digit are not significant figure. It means if I'm going to ask you how many significant figures you have for example 1, what you're going to say, this 0 is not significant, this 0 is not significant. It means 1, 2, and 3 digit are significant. It means there is 3 significant figures are that in the given number. All right. Now let's take the second example. In this example, what we can say, if the number is less than 1, in this case, yes, it is, then all the zeros before your first non-zero digit are not significant. It means this 0 is not significant. Let's count how many digits we are left with. 1, 2, 3, and let's say there is 6, right? 4, right? There are 4 digits. It means the answer is 4 significant figure. All right. Do you guys follow this?
Yep.
Right.
Yeah.
So excellent, excellent, excellent. Right. We're going to practice on this kind of problem tomorrow, so it will be more clear to you, right? The second rule, where we are not going to count this 0 as significant figure. But for that, there is two condition. What is the condition 1? Condition 1 says the number has to be greater than 1, right? A number has to be greater than 1 and does not have a decimal point. Let's say if you have a number like this, which we already know, like 148,000. I did not put any decimal. However, if you want to read this, you can say 148K, right? It is a number which is greater than 1 and does not have a decimal point. Then what we can say, all the trailing 0. What do you mean by trailing 0? The which are present on the tail, or we can say on the right end of the number, are not significant figure. It means all the 0 which are on the right side of the number, in this case these are 3, are not significant figure. It means we are not going to count this as a significant figure. So how many digits we are left with? 1, 2, 3. So answer is 3 significant figure. All right. Do you guys follow this? 4, 8.
Yes, sir.
Yeah. All right. Let me ask you this. If we have a number like this, how many significant figure do you think there are?
2.
2.
Very simple. However, remember, right? It has to meet the requirement. What is the requirement? The number has to be greater than 1 and it does not have a decimal point. If it does not have a decimal point, then all the trailing 0 which are at the end of the end of the number are not significant. It means there are 2. Okay. I just want, before we kind of wrap up, let me just give you one exception which you kind of have to understand. If I give you the same number with 0 and the decimal point, now what should be your answer?
Eight.
Yes, it's very simple.
8.
Excellent, right? All we have to keep in focus is if we are following the rule, if it meets the requirement, then we are following the rule. It doesn't meet the requirement in this case. The number has to be greater than 1. Yes, it does follow that requirement and does not have decimal point. In this case, we do have a decimal point. It means we cannot apply this rule. Anyway, the number is greater than 1, so we cannot apply the first rule as well. What it means, if we cannot apply any of those two rules, means every digit you see in the number are significant. It means 1, 2, 3, 4, 5, 6, 7, and 8. So your answer is 8 significant figure. All right. So what I would ask you to do, I'll just ask you to take the picture of the screen. Right. Already you have this kind of in your handout that I gave it to you. Please refer to this rule. We are going to practice on this, build up our knowledge on this tomorrow. All right, because it's already 1. I don't want to kind of hold you for a longer time. So I'm gonna give you 15 seconds to take the picture in case if anybody like to do.
Can I stay? Because I have questions.
Oh yes, definitely. Right. Of course you can stay. All I'm going to do, I'm just going to stop kind of recording this session, right? And I'm just gonna say goodbye to most of you guys, whoever wanna leave, and then I'm gonna continue, right? If you have a question, I can answer that question. So I'm gonna stop sharing this. turn on my camera. It's me. All right, guys. So thank you so much for your time. I hope this session was helpful. I'm gonna stop recording.
Thank you, Professor. Have a nice day.